Okay, so we're going to look at Dijkstra's algorithm, which is for shortest path between any 2 points on a simple connected graph. And so what you see is a graph here with weights, and we want to find the path of least weight to get from A to Z. Now, if you eyeball this graph, you'll probably notice that the shortest path is definitely from A to B to C to Z with a length of 5, because it looks like a lot of the weights are actually greater than 5, or at least 5. So it seems plausible that that is the shortest path. So naturally, to test the algorithm, let's see if we get the same thing, right? So it's all about organization, and there's different ways of organizing this information, but I'll just show you the way that I like the best. So I'm going to start with A, because that's our starting point, and I'm going to visit every node possible from A, and then calculate the path, and then we'll take the shortest, and then go from there. So from A to A, we know is 0. From A to B, we know is 2. From A to C, we can't reach that, so we're going to call that infinity. And the same thing with D, and the same thing with E. But from A to F is only 1 unit. From A to G, we can't get directly there. And from A to Z, we can't get directly there. Now, it's going to be a little bit much to keep track of. So what I'm going to do is, for at least the numerical ones, I'm going to put a subscript that shows where we started from. So this 0 started from A, this B started from A, and this F started from A. Now, as we go through, we're going to be updating this, and I'll be changing the subscript to know what was the last node we visited to get to that shortest path. So at this point, here's what we have done. We have visited node A, and we have traversed edge from A to B and edge from A to F. And it looks like I'm going to be using F to go forward because that's my shortest distance from A. So I'm going to go to F next. And I'm going to jot down the ones we know we're using. So that's those two. Now, I'm going to highlight them so that we know those are done, right? We're not going to be, after this point, we're not going to be trying to find the shortest path to go to F now because we know it's not going to get any shorter than what it is. So from F, we can get to, and I'm going to try to change the color up every time, we can go to D, or we can go to G. So if we go from F to D, that adds another 3 units to the already 1 unit path of F. So from F to D would be 4 units. And I'm going to put a subscript of F there to denote that F was the last place I was at. And then F to G would be 6 units because I'm adding 5, the weight of 5 on the graph there, to the 1 already traversed unit. All the rest are going to remain the same. So I'm going to write 2A, infinity, infinity, infinity. And now what is the next shortest one? It looks like we're going to be going to B next. So B is going to be next visited. I know that there's no better path to go to B, so I know that one is done. And you notice I'm just highlighting the ones we did because that's just easier to keep track of as we go. So here we are at node B. So we've already traversed 2 units from A. So to get to, so it looks like we're going to get to, what color do we use next? I'll use green. We can go to D, we can go to C, we can go to E. So we got a lot happening here. Well, to go from B to D, that's 2 more units, and you notice so that makes a total of 4, and you notice we already have 4. So we are not breaking anything here. We're not less than 4. So that means we're just going to keep that one the same. We only change when we find a shorter path. To go from B to C, well, that's a length of 4, and that's new now. So that's 4 coming through B. And then from B to E, we could add 4. So that means a path of 6, and yes, that is less than infinity. So B has done a lot for us this time. Everything else is going to remain the same. And the only node that we haven't even gotten to yet is Z. That might be coming, who knows? So out of the highlighted ones, we have 0, 2, and 1, so those are done. Now we choose a next shortest path, and that would be C. So I'm going to visit C next. So these all stay the same. And then we visit from there. And I hope it's not confusing that I'm changing the color every time. I'm just trying to be a little expedient about it so I'm not caught up in my technology here. So from C, what can we visit? Well, we can visit E for a price of 3 more units. Now, the shortest path to C is already 4. So if I add 3 more, that's 7. That's not going to help me. So that's going to stay the same. And then it looks like we can actually get to Z now for a total length of 5. Could that be the shortest path? Because we already kind of thought so. And then that means everything else stays the same. So let's see what happens next. Now, taking the shortest of all of those, looks like D is the ticket because that has the 4F underneath it. So we're going to be visiting D next as soon as I update my edges. So from C, we visited E and Z. So here we go. We're going to now visit D and just traverse the remaining edges. Well, so the shortest path, so again, copying these down, it's probably the part that's the worst to remember. Okay. So the path from D, well, let's look at that. All the possible places we could go from D. We could go to E. That's it. That's the only edge we haven't visited yet. So to go from D to E, well, the path to D already has a length of 4. Adding 4 more would be 8, and that is not under 6, so that stays the same. And that means the rest of these stay the same. And looks like Z is next, because that is the shortest path. So, all of these are staying the same. All right, so now we can go from Z to G, which would add 6 more to the already 5 units to get to Z, so that would make 11. We're not going to do any better there. So, okay, that pretty much does that for us. Now, so what's the next new one? Well, as soon as I highlight these, we have a tie again. So I'm going to use E. And even though we have figured out what the shortest path to Z was, it is 5. Let's just finish this out anyway. So this will be our next one. So we're going to visit E next. And E, oh, I think I missed one. We already visited that one. So with E, we can only go to G. So that means all of these are going to stay the same. So let's see what, oh, and that means this is now there. So we can only visit G, and that's going to add 7 to the already 6 units to give us 13. We're not going to do any better than that. So this means we're all done because we have nowhere else to visit. We have traversed every single edge. So from A to Z, let's take a look at that bottom row now. So we started here at Z. Now that came through C. So going under the column for C, it was a B. So going under the column for B, there's the A. And that's basically it. So it was A to B to C to Z, length 5. Now, if you're curious about the other ones, the shortest path from A to G, let's take a look at that one. So from A to G, well, 6 came through F and 1 came through A. So it was A to F to G. And again, looking at that bottom row, you can tell what is the shortest path between A and any other node on the graph. So hopefully that helps to illustrate Dijkstra's algorithm. What we eyeballed at the beginning is actually what is true. The shortest path A to Z is 5, but now we got more than we bargained for with the rest of the bottom row. So thanks for your time.